Hello, everyone. In this video, we're going to write the equations of these graphs, and we're going to check our transformations after we do that. So the very first thing that we're going to look at is problem number 1, and we're going to attempt to write the equation for this. So every equation or formula, or sorry, not formula, function is always going to start with either y equals or f of x equals. So let's just be fancy and write f of x equals. Okay, and we're going to start with the reflecting over the x-axis. So since this function reflected over the x-axis, that means there's going to be a negative out in the front. The next thing is this vertical stretch by a factor of 2. That means that our a value, or the number in front of the absolute value, was 2. So we're going to write 2. Now we're going to draw our absolute value signs. We're going to draw our x. Then it goes right 1. And remember, right, usually we think positive, but we need to think the opposite. So this is the weird one, remember. So since we're going right 1, this is actually going to be -1. Then we're going to go up 3. Okay, so plus 3 on the end. All right, so let's check our work with this one. We're going to type this in and see if it gives us the exact same equation that we had on our paper. So let's go to Desmos. And we're going to type in -2, absolute value of x minus 1 plus 3. Okay, and you can see that the vertex is here at 1, 3. That's exactly the same as on our paper. And it's going down, down to, sorry, that was looking really weird, right 1. Down to right 1, okay? So this does have our same slope. And we can see that it's crossing at 2.5 between 2 and 3. That's the exact same as our graph. And it's going through the y-axis at 1. So this is our graph. We have stated the transformation correctly because it gave us the correct equation. Okay, so let's look at our second one. And let's just write y equals this time, because why not? This one's not reflecting over the x-axis. It's not doing a vertical stretch. So we're just going to go straight to the absolute value sign. And we're going to write our x. Okay, left 3, usually left means negative, but now we have to think the opposite. So left means positive 3. And then the down 1, that's just going to be normal. So it's going to be -1 on the end. And that's actually all for this equation. So let's check and make sure that this did the correct thing. So let's go to Desmos. Okay, and we can see the vertex is down here at -3, -1. That's the exact same as our graph. The slope is also going up 1, right 1, up 1, right 1, up 1, right 1. So that's good. And it's the exact same width. That's because the slope is the same. And it's going through the y-axis at 2 and the x-axis at -4 and -2. So this is the exact same equation that we have on our paper. We are good to go. That means we did our transformations correctly. Okay, and let's look at our last equation, and let's just write g of x equals, because that can be another thing that you see. So the first thing that I see is reflect over the x-axis. That means there was a negative out in the front. The next thing is a vertical shrink by a factor of 1/2. So that means I'm going to put a 1/2. Then I need to put my absolute value sign, and it's going left 1, up 2. Left now means positive, so that's +1. And then up 2 is +2. Okay, so let's check this last one in Desmos. All right, here we go. And we're going to do -1/2, absolute value of x +1 +2. And we can see that the vertex is at -1, +2. That's the same as our graph. The slope is going down 1, right 2. Down 1, right 2. That's the same. And it's going through 3 on the x-axis and -5. That's good. And it's also going through 1.5 on the y-axis. So we're all good. That means we've done our transformations correctly. And we have also learned how to write out an equation. So let me just put this back up here real quick. There it is. So that's awesome. And we are good to go. So I hope you guys have a great rest of your day. Goodbye.